Welcome back, learners. So now to jump to our first concept being the electrical power, we need to understand what is meant by electrical power. So electrical power refers to the rate of electrical energy that is supplied. So basically, electrical power refers to the rate. Remember, rate means dividing by time or measuring it over time. So electrical power refers to the rate of electrical energy supply. Then the electrical current, which is the charge that flows through a circuit, transfers electrical energy, which is denoted by E, so E stands for energy, to the electrical appliances in a circuit in order to power them. So remember that the circuit that you're talking about here, it can either be connected in parallel and it can also be connected in series. However, the most important thing that you need to remember here about this electrical power supply is that the electrical charge, it flows through the circuit and it transfers the electrical energy to the appliances in order for them to function. So in order for those appliances to function, they need the electrical energy. Then the energy transferred is equal to the amount of work. So the energy transferred is equal to the amount of work done by the charges. So the amount of energy that is transferred or the work that is done is measured in joules. So the energy is measured in joules, and also the work that is done is measured in joules. So joule is the measure of energy for work and also measure of energy for the unit of measure for energy as well. So the rate at which work is the rate at which energy is transferred or at which work is done is known as power. So if you were to define or to describe power, you can just simply say that's the rate at which energy is transferred, or you can say the rate at which work is done. So therefore, power is actually equal to the energy transferred per unit of time. Remember, the moment we talk about rate, that means now that we are measuring something over time, over a short period of time or over a long period of time. The most important thing is we are measuring over time. Then the SI unit used to measure electrical power is watt, which is denoted by capital letter W. So 1 watt is equal to 1 joule of energy transferred or work done per second. So 1 watt is equal to 1 joule of energy transferred or is equal to work done per second. So now that simply means 1 watt, which is the capital letter W means watt, is equal to 1 joule per second. So in other words, this can be written as 1 joule over 1 second. So that is equal to your 1 watt. So 1 joule over 1 second is equals to your 1 watt. Which then means if we have 1 kilowatt, that simply means we have 1000 watts. So 1 kilowatt is equals to 1000 watt. And remember, 1 watt is equal to 1 joule per second, or 1 joule over 1 second. So we also need to know that different appliances, they need different amount of electrical power to function. So we do know that we have different appliances at home, and each one of those appliances, they use different amount of energy or a different amount of electrical energy. So the same thing applies here, that different appliances, they need different amount of electrical power to function. A stove is going to need a different amount of electrical power as compared to a cell phone, as also compared to a fridge, as also compared to a kettle. So all of those appliances, they need different amount of electrical power for them to function. For example, we know that a hairdryer is also one of the appliances. Now a hairdryer that is marked 2000 watts, it means it is going to be using 2000 joules of energy per second. So in each second, this hairdryer that is marked 2000 watts, it is going to be using 2000 joules of energy on each second. Whereas a light bulb that is marked 15 watts, it simply means that light bulb is going to be using 15 joules of energy per second. So each of these ratings of these appliances, they denote how much energy is going to be used by each appliance per second. Remember, 1 watt is equal to 1 joule per second. So should we have, as we have here, should we have 2000 watts. That simply means we are using 2000 joules of energy per second. So whichever wattage that we have, it is going to be used per second. Now, the wattage needed to power an appliance is also called its power rating. So every appliance, if you want to check the power rating of each appliance, you need to look at the back of the appliance to check the power rating of each, because that is going to tell you how much energy is needed by that particular appliance for it to function. And remember, that energy is going to be used per second. In this case, we have used a hairdryer as an example and a light bulb to say a light bulb that is marked 15 watts, it is going to be using 15 joules of energy per second. So before we go to the next concept, we're just going to quickly go for a short break, and I will see you just after this.